Thanks for coming to the YouTube channel Mr. Professor or 교수 아재 in Korean. In this video, we handle a problem related to the number of non-negative integer solutions to an equation. Given an equation, the sum e sub 1 through e sub n equal to r, we want to count the number of non-negative integer solutions to the equation. For example, suppose that n is equal to 3 and r is equal to 7. So you can think about this equation. We can easily find some non-negative integer solution to this equation. For example, 1, 4, and 2. Well, this one actually can be also expressed as like this. So there are 3 distinct boxes, okay, 3 distinct boxes. And in the first box, we have 1x. And in the second box, we have 4x. And in the third box, we have 2x. So to distinguish between first and second and third box, we kind of put bars like this, okay? Or we can also express this one. There are 9 x's here. And then we chose the 2 x's there. So second position x and the 7th position x in here. Then it seems like this is like a bar to distinguish first and second and third boxes. Like the same situation. Okay. Well, you may think about another integer solution, maybe 2, 3, and 2 also. So in this case, you just want 9 x's again in here. And then, well, you want to choose third x and the 6th x. So then those 2 x's can be played like a bar, okay, like bars. So in the first box, we have a 2 x's like matches 2. And we have a 3 x's like matches here, this one, and 2 x's like matches in here. So the number of integer solutions to this equation, okay, is actually, you just want to choose 2 x's out of 9. So that's, so you want to choose 2 out of 9 in here. But this 9 actually comes from where? 7, this is 7 plus, and 2 bars. And so actually we have 3 distinct boxes, okay? And then you want to just subtract 1, okay? Then that kind of, we have 2 bars. So this is kind of 2 bars or 3 distinct boxes in here. So and these 2 actually 2 bars or 3 distinct boxes from here. So more generally, okay, this equation, okay, to count the number of non-negative integer solutions to this equation, actually, because we have r in here, so r plus, and we have n distinct boxes, which means we have n minus 1 bars. And then you want to choose n minus 1 bars, or you want to choose r. So here is an application of this. So given a set 1 through n, okay, so we want to count the total number of k-element selections, okay, but there is a condition that do not contain any 2 consecutive integers. Okay, well, okay, so think about such a selection, okay, so maybe you can list all the integer 1 through n. So 1, 2, 3, up to n in here. And then you want to choose k elements there. Okay. Well, if there is no restriction like this, then that exactly matches n choose k. Okay. But we can also think about this one like the previous slide. Okay. So if you choose k elements in here, okay, then well, you can think about those k numbers like a bars, like a k bars. Then we have k plus one distinct boxes. K plus one distinct boxes. Okay, and then we want to count the number of integers there. Although in the previous slide, we count the number of x's here. Okay, so we can actually express this one is you can express this one is there are k plus one boxes in here. Okay, and because we already used the k integers in here, so only n minus k integers are left, and then we want to distribute actually. Okay, so that's why we have this one. So by applying the idea of the previous slide, that's m minus k plus, we have a k plus one distinct boxes, which means we have a k bars minus one, and then you want to choose k. So this is also exactly matches and choose k. Okay. So the reason why we think this problem in that way, because if there is a constraint like this, then we still can apply this idea. Okay. Because we have constraints that do not contain any two consecutive integers. So that means E sub one can be 0 because you can choose one, okay, from k element selections. You may choose one also possibly. So E sub one can be 0, but if you choose one, then next one cannot be 2 because we have restriction. Okay, so that means E sub 2 is greater than equal to 1. Similarly, actually up to E sub k is also greater than equal to 1, right? Well, because you can choose n actually for k element selections, okay, so E sub k plus 1 also possibly 0, okay? So if you can set up like this, actually you can translate this one like x sub 1 plus up to x sub k plus 1 is equal to m minus k because we have this constraint. Okay, so that means each box from second box to the case box, okay, we have to use at least one integer there, which means that we already consumed k minus 1 integers there. So this is equal to m minus 2k plus 1. Okay, and then x sub x sub 1 through x sub k plus 1 is greater than equal to 0. Then we can apply the idea, the previous slide. So then you want to count the number of integer solutions in here. So that's m minus 2k plus 1. And plus there are k plus 1 boxes, which means that there are k bars. And then you want to choose k plus 1 minus 1. So this is equal to m minus k plus 1 choose k here.